In this supplemental video, we're going to discuss how to multiply polynomials. Now, it's not as hard as you think because the basics of all of this is distributing. So if I gave you something like 3 times the sum of 5x and 2, all you would do is multiply 3 times the entire sum, and you would get 15x because that's 3 times 5x, and 3 times 2 is 6. And your answer would be 15x plus 6. But since in this case we're talking about polynomials, remember poly means many. So we could have monomial, which would be one term, binomials, which would be 2, trinomials, which would be 3. All it means is now distributing more than one term. Like for example, in this problem, you're taking a monomial times a binomial. So what would happen if I gave you this? X plus 4 times x plus 2. Now what you're going to do is you're going to be distributing. But now, instead of just like distributing a 4, you're going to multiply everything in one set of parentheses to everything in another. And this actually would be multiplying a binomial times another binomial, because that means we have 2 terms here times 2 terms here, which should give us 4 terms overall. So all you do is you start with the x, and we're going to distribute the x. So x times x, remember, the properties of powers state that if you take x times x, same base, we add the powers, that gives you x squared. And then you take x times 2, and you get 2x. Then you distribute the 4. We take 4 times x and 4 times 2. Well, 4 times x is going to give us 4x, and 4 times 2 gives us 8. I then add together the 2 like terms in the center, 2x plus 4x. That's going to give us x squared plus 6x plus 8. This is a trinomial, 1, 2, 3. Since none of these are like terms, this is my final simplified answer of x squared plus 6x plus 8. Let's do another example. 2x minus 7 times 3x plus 5. Once again, we distribute. We distribute the 2x, and then we distribute the negative 7. So I multiply 2x times everything in the other parenthesis, and then I multiply negative 7 times everything in the other parenthesis. So 2x times 3x, don't write 6x because that's what a lot of students make the mistake of. 2 times 3 is 6, but x times x is x squared. So 2x times 3x would give us 6x squared. 2x times 5 gives me 10x. Negative 7 times 3 is negative 21x. And negative 7 times 5 is negative 35. I now combine like terms in the center, and that gives me 6x squared minus 11x minus 35. And that's my answer. Now we're going to multiply binomials with more than one variable. Follow the same rules. I take the 5x and I distribute that, and 5x times negative 1x will give me negative 5x squared. Then I take 5x times negative 7, that gives me negative 35. Now, common mistake, I just made it. Make sure you have the letters. The best way to do it is to always put the letters in alphabetical order. So 5x times negative 7y would be negative 35xy. Now I'm going to distribute the negative 2y. And negative 2y times negative x would give you positive 2xy. And negative 2y times negative 7y would be positive 14y squared. I now combine the like terms in the center. That gives me negative 5x squared minus 33xy plus 14y squared. So then what happens when you have this? 2x plus 5 times 3x, let's do plus 7y minus 11. What happens now? Well, now it's the same process. You're going to multiply 2 terms here times all 3 terms here. So you're going to multiply everything in this set of parentheses, this binomial, times everything to this trinomial. So 2 terms times 3 terms, you're going to have 6 terms overall. So let's start distributing. I'm going to distribute the 2x. So 2x times 3x gives me 6x squared. 2x times 7y gives me plus 14xy. 2x times negative 11 gives me negative 22x. Now I distribute the positive 5. 5 times 3x gives me 15x. 5 times 7y gives me 35y. And 5 times negative 11 gives me negative 55. So now you combine like terms. 6x squared, that's the only one. Are there any other xy terms? Nope, so plus 14xy. Now, these two I can combine together. Negative 22 plus 15, that gives me negative 7x. And then plus 35y minus 55. So this is the polynomial that I have left. And that's pretty much the basics of multiplying polynomials.